Hello everyone, hope you are doing well. This is Aisha here. Today I am going to discuss the BFS process in the video. So without any further ado, let's get right into it. So if we want to traverse a graph, there are two easy techniques available, which are DFS and BFS. Now let's look at the graph traversal of BFS. In BFS, the nodes of undirected graph are visited in a symmetric manner so that every node is visited exactly once. It gives rise to a tree. When a node X is visited, it is labeled as a visited and it is added to the tree. If the traversal got the node X from node Y, Y is viewed as the parent of X and X a child of Y. Now let's take a look at the rules of BFS. BFS follows the following rules. Select an unvisited node X, visit it, have it be the root in BFS tree being formed. Its level is called the current level. From each node Z in the current level, in the order in which the level nodes were visited, visit all the unvisited neighbors of Z. The newly visited nodes from this level from a new level that becomes the next current level. Repeat step 2 until no more nodes can be visited. If there are still unvisited nodes, repeat from step 1. Here we gave a glimpse of BFS tree of graph G. Now let's look an example of BFS traversal by which the process can be explained more easily. We used 3 different colors that indicates 3 different situations that are white, grey and black. White vertices have not been discovered. All vertices start out white. Grey vertices are discovered but not fully explored. They can be adjacent to white vertices. Black vertices are discovered but not fully explored. They are adjacent only to black and grey vertices. Explore vertices by scanning adjacency list of grey vertices. So initially all the vertices are white, which means they are not discovered yet. Now in the following slide we can see that S is fully discovered and its adjacent vertex, which is R and W, they are not fully discovered, they are just explored. That's why they are grey. And S became black. After that, W became black and its adjacent vertex T and X became grey. That means W is totally inaccessible and T and X is now explored. Similarly, R is totally discovered and its adjacent vertex V is now explored. That's why V is in the color grey. Now V is fully discovered and also T and X. The adjacent vertex of T and X are being explored and that's why they became grey. Now U is discovered and the last node Y is discovered after that. This is how we traverse a graph using BFS, and if we give a conclusion, it is seen that a vertex is being traversed only once. We will see the BFS implementation using queue. Here firstly, the parent node will enqueue in the queue and it will fully discovered and then dequeue from the queue and enqueue its child. Now let's briefly explain the process. Pick a node and enqueue all its adjacent nodes into a queue. Dequeue a node from the queue, mark it as visited and enqueue all its adjacent nodes into a queue. Repeat this process until enqueue is empty or you meet a goal. If we recall the diagram explained few moments ago, we saw that S was the first node to be discovered. That's why it will enqueue at first. Now S will be dequeued and its adjacent vertex W and R will be enqueued. After that, W will be dequeued and its adjacent vertex X will be enqueued and also the adjacent vertex T. And then R will be dequeued and its adjacent vertex V will be enqueued. The same process goes for T and U, and then lastly Y will be enqueued. After that, V, U and Y will be dequeued one by one. And finally, the queue will become empty. This is how we can implement BFS using queue. Here I have shown a pseudocode of BFS where all the unvisited vertex will be enqueued and the visited vertex will be dequeued. And there is a condition that will check if the queue is empty or not. So it was a brief discussion of BFS and its implementation. That's all for today. Thank you.